Today we're going to continue our discussion on systems of linear equations, and we're also going to talk about Chinese mathematics. So I want to discuss the history of Chinese mathematics a little bit because what they did in the past had a significant impact on the mathematics that we're learning today. The Shang dynasty used oracle bones that are the source of our knowledge of early Chinese number systems. Some of the mathematical texts during the Han Dynasty were the Book of Numbers and Computation, the arithmetical classic of the Gnomon and the Circular Paths of Heaven, and the 9 chapters on the mathematical art. Almost like our textbooks today, these texts consist of problems and their solutions. So it's definitely almost, because your textbooks do not have these solutions. The Chinese made many advancements. In particular, they were one of the first ones to acknowledge negative numbers. They also made advancements concerning fractions, square and cube roots, areas and volumes of geometrical figures, the Pythagorean theorem, polynomial equations, and they saw congruences using the Chinese remainder theorem. And they also made advancements concerning systems of linear equations, which is what we're concerned about today because that's what we're learning. The 9 chapters contains the 2 basic algorithms for solving systems of linear equations. The first method is called the method of surplus and deficiency. Today, that is called the method of double false position. You begin with guessing possible solutions, and you end by adjusting your guess to get the correct solution. This showed that the Chinese understood the concept of a linear relationship. The second method is almost identical to the method of elimination that is used in our classrooms today to solve systems of equations. So if we're looking at how the Chinese use the second method, we can look at this problem. If 1 plum and 3 peaches weigh a total of 750 grams, and 2 plums and 1 peach weigh a total of 500 grams, how much does a single peach and plum weigh? So if we look at the contents of the first scale, which is the first 1 plum and 3 peaches weigh 750 grams. That's our first scale. So if we double that, we add it twice, we get 2 plums and 6 peaches equals 750 plus 750, or 1,500 grams. So the next step they took was to subtract from this the contents of the second scales. So they took what they got in the first step, and they subtracted their second scale, which was 2 plums and 1 peach weigh 500 grams. So they subtracted the second from the first step, and their 2 plums canceled out. They got rid of their 1 peach, so they were left with 5 peaches equal to 1,000 grams. So 5 peaches weigh 1,000 grams, and we wanted the weight of 1 peach. We can divide 1,000 by 5, which gives us 200 grams. Their last step was to take the peach off of the second scale. So we have our second scale here, and they take away 1 of their peaches, and they were left with 2 plums, which equaled 300 grams. So 300 divided by 2 equals 150 grams. So if we want to look at how they use the second method in a more algebraic sense, we can make the plums equal to x and the peaches equal to y. So if we have 1 plum and 3 peaches that weigh 750 grams, we can say x plus 3y equals 750. And if 2 plums and 1 peach weigh 500 grams, then we can say 2x plus y equals 500. So looking at their first step, they double the contents of the first scale. So our first scale can be our first equation. So when we double our first equation, we get 2x plus 6y equals 1,500. Their next step was to subtract from this new equation the contents of the second scale, which would be our second equation. So when we subtract our second equation, we get 2x minus 2x, which equals 0, 6y minus y, which equals 5y, and 1,500 minus 500, which equals 1,000. So if we divide by 5 on both sides, we get y equals 200. So now they took the peach off of the second scale. So our second scale is 2x plus y equals 500. We know y equals 200, so we have 2x plus 200 equals 500. When we subtract our peach, which is equal to 200 from both sides, we get 2x equals 300. When we divide by 2, we have x equals 150. So we see that one peach equals 200 and one plum equals 150, just like we found on the left side. So we know the four main methods used to solve systems of linear equations, and we've already learned about graphing and substitution. So today we're going to discuss elimination. The elimination method is also called the addition method. So for solving a simple equation like x minus 6 equals 11, then we can put 6 under our equation here, and if we add down, so if we add vertically in columns, we have x plus 0 equals x, a negative 6 plus a positive 6 equals 0, and 11 plus 6 equals 17. So we have x equals 17. We were able to solve this by adding down in columns. So this is similar to the elimination method, except the elimination method involves more than one variable. So we can have x and y, or we could have x and y and z, and you have to add your variables. So we can use the same idea to solve a system of linear equations, such as 2x plus y equals 9 and 3x minus y equals 16. So if we look at this system of equations, and we're thinking about if we add down, well, if we add down here with our y's, then our positive y and our negative y will cancel out. So if we go ahead and add down our equations, we have 2x plus 3x equals 5x, positive y plus a negative y equals 0, and 9 plus 16 equals 25. And if we divide both sides by 5, then we have x equals 5. Now that we have x equals 5, all we have to do is plug x back into one of our equations to solve for y. So if we pick our first equation, 2x plus y equals 9, and we know that x equals 5, then 2 times 5 plus y equals 9, which gives us 10 plus y equals 9. And if we subtract 10 from each side, we have y equals negative 1. So our solution is xy is equal to 5, negative 1. Another example here, we have the system of equations x minus 2y equals negative 9 and x plus 3y equals 16. So if we're looking at it from the viewpoint of we need to add down and cancel something out, well, if we add down here, we get 2x. If we add down here, negative 2 plus a positive 3 would give us 1. Nothing cancels out. So if this x happened to be negative and we added down, if one of them was negative and we added down, then our x's would cancel out. So in order to make one of our x's negative, we can multiply one of our equations by 1. I'm going to choose the bottom one, but it really doesn't matter which equation you choose. So we have x minus 2y equals negative 9. And then after we multiplied our second equation, we got negative x minus 3y equals negative 16. So when we add down, we have an x plus a negative x, which gives us 0. We have negative 2 plus a negative 3, which gives us negative 5. And we have a negative 9 plus a negative 16, which gives us negative 25. So if we divide by negative 5 on each side, then we get y equals 5. And just like we did before, we can plug our y back into one of our equations to find what our x value is. So if we plug our y back into our first equation, then we have x minus 2 times 5 equals negative 9, which gives us x minus 10 equals negative 9. And if we get x by itself, we need to add 10 to both sides. So when we add 10, we get x equals 1. So our solution is xy is equal to 1, 5. And now when we do a problem like this, we just happen to find our y first and our x second. But when we write our ordered pair, we always want to remember that our x is first and our y is second. So I don't want you to get confused, maybe get them mixed up. So when you do something like this, just double check to make sure that you didn't accidentally put your y first just because you found it first. So our last example we have here is 2x minus y equals 9 and 3x plus 4y equals negative 14. So when we're looking at it again and seeing what happens and we add down, nothing will cancel out. But if we look a little closer, we have a negative and a positive here. This y has a coefficient of 4. Well, if this y had a coefficient of 4 and we add it down, then they would cancel out. So in order to get a 4 here, we can multiply our first equation by 4. So when we do that, we get 8x minus 4y equals 36. And then we can add down with our other equation. So we get 8x plus 3x equals 11x. A negative 4 plus a positive 4y equals 0. And 36 plus a negative 14 equals 22. And we can get our x alone by dividing by 11 on each side, which gives us x equals 2. And once again, we can plug in our x value to one of our equations. I'll pick the first one because it looks a little bit simpler. So we have 2x minus y equals 9. When we plug in our value of x equals 2, we get 2 times 2 minus y equals 9, which gives us 4 minus y equal to 9. And then we have a negative y equal to 5. And we can divide by negative 1 on each side to get y equals negative 5. So our solution is xy is equal to 2, negative 5.